um, about the pump combination curve. Why are there so many curves? Well, we have here 4 pumps, right? So 2 of them, the small ones, share the small pump curve, which is this listed here on the right, and the big ones share this other um, pump curve. This pump curve means the name, if you remember. Let me go back here. I'm not going to save this. The pump definition for this one is 3500-200. And that means that the design point is 3,500 gallons per minute of flow, and that at that flow it produces 200 feet of head. Okay, so if that's what it has to pump, that would be the perfect operating point for it. Now look at the efficiency that we set. We said it is most efficient when it runs exactly at its design point of 3,500 gallons per minute. And the efficiency is 70%. Okay? So the scale on the right shows the pump efficiency. The scale on the left shows the pump's head. All right, so remember that. For the other pump, it's the same. The flow is, the design flow is 2,000 gallons per minute, and the head also 200 feet. So these two share the same head. And the efficiency is 70% at that design point. Okay. Now with that in mind, let's go back to the combination pump curve and notice all the possibilities. Let's go one by one. Okay, so I'm going to turn them all off for now. Maybe start with one at a time, and this might make more sense. Okay, so what is this curve showing us? It's showing us the scenario where we have only one of the big pumps on. Okay, when you see this head 0, 0 is the ID. Okay, so that's when we only have one big pump on. What if I had 2 of the big pumps on? Then you get to see this is the original that we had for only one pump on, and this is the 2 pumps on. Okay, so I'm not showing you system head curves just yet. Then what is this other combination with ID2? ID2 is what happens when we only have one small pump on. What would the pump curve look like? Let me click it. And you can see that's the small one. So small one big one, red means 2 big ones, and so on. So you can see all the possible combinations. We're not going to go one by one, but let me just show you this, for example. What would happen if I have 2 big pumps and 2 little pumps all on at the same time? This would be the combined pump curve of all 4 of those. Okay, now let's introduce one system head curve at a time and start analyzing it this way. Okay, so for the boundary conditions established at hour 0, this green line represents the system head curve. So if I were to turn all 4 pumps on, then it would be my operation point would be at the intersection of these 2 lines. If I only had one big pump on, this would be the flow. Okay? So that's really what it's telling me. And you can start adding more complexity if you say, okay, I also want to see the efficiency curve. Okay, so what is this efficiency curve? It's the 70% efficiency that we looked at originally if we were operating at 2,000 gallons per minute, right? So it would be most efficient. Let me just start removing one at a time because this should be, sorry, that wasn't the big one. That's what it is. It's the 3,500. It's a big one. So at 3,500, our efficiency should be 70%. Okay? But now look at what happens if I have the two big ones and the two little ones on at the same time. I'm going to close here and show you one thing. So when we input our design point, notice that we were really, that's the only information that we're giving. So using this coefficients here, it generates a standard pump curve. So it actually extrapolates to find that. Okay, perfect. So yeah, as I was mentioning, we input this, so the software calculates that all the other points, you know, like the shut-off point and the maximum operating point, which would be that maximum flow that you were referring to. So let's see, let's go back here and go to our combination pump curve. And I'm going to leave this combination of one big and one small. So you can see that it's combined the curves, and they kind of do add up, you know, almost perfectly. I think the maximum flow was 7,000 for one and 4,000 for the other. So in terms of flow, it's just almost 11,000 here. Okay, so let me see. That was the question was, what is the maximum flow of the two pumps when both are on? So that's your theoretical maximum flow, right? But because the operating point would actually be here when one big one and one little one are on, in this case, we'll have a flow of like 5,500. Yeah. So that's, again, that it is obtained by interpolating the system head curve, which is independent of the pump, simply with the point where it would meet the combined pump curve. Yes, so this is done because remember we have this system, and let me just back up here for a minute. The system that we have has this pump, or this pump station rather, and it has a tank here. So it can virtually produce any flows, right? So that's how we're generating that system head curve. Because if we, you know, add one more pump, then, you know, it'll be just more flow that goes into the tank, you know, and we're only looking at this in that particular moment. You know, we'd have to actually run the simulation to see what would happen in the entire system. But that's how we're able to see what is happening. So let me go back there. Okay, so the pump curve, you know, it's basically adding up the two pump curves that we gave it, and the system head curve at that intersection point is how we come up with that operating point.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.